Yeah. I'm not sure what's competitive. She wants to know you do. No. It's competitive.
All right. Assume that wasn't a question. Somebody just might, because it opens up from sound, the mic. All right. So take a gander at number 20. It says factor completely. All right. Now, this is a good one to start with because really what we're dealing with when we have something to factor, we should always look at whether there's a greatest common factor. If we can find a greatest common factor, that may well make things easier for us. So is there a greatest common factor between 20, 49, 28, and 4? I was kind of hoping there was, but I'm thinking not now that I'm looking at it. All right. Well, look at the ends. Look at the first term and the last term. Those are what we call perfect squares. In other words, 4 is 2 squared. All right. And also, um, this right here is 7x squared. So that gives us a hint about how to proceed with this one. We can go ahead and multiply the 49 times the 4 and use my AC method to do this. But um, you don't necessarily have to go there unless we can figure out this pattern. If we can figure out this pattern. All right. So let me just show you. This is what we call, I think this is what we call, if I'm not mistaken, and I have to look at it too. This is what we call a perfect square trinomial because the ends are perfect squares. In other words, 4 is 2 squared and 49 is 7x squared. And then what we're going to do is if we can get 7x times that 2, that gives us 14x. And then we multiply it by 2 again, we got 28x. So what we got here is a perfect square trinomial. In other words, we're going to take 7x and put it there. And then over here, we're going to put the 2. And then we put this sign right there. And then square it. In other words, this is 7x minus 2, 7x minus 2. So this is probably the way, way you usually see it written. But that's a perfect square trinomial because the ends, so that's 7x squared, because 7 times 7 is 49, x times x is x squared, 2 squared is 4, and then 2 times 7 is 14, times that 2 gives us the 28, and it's negative in the middle because that term's negative. All right, any questions about that one? All right, look at that next one up there. Another one that's gonna, well, actually, what's the greatest common factor on this? This will help us. What's the greatest common factor between all the terms? What do each terms have? there's no common factor between 4 and 9, so we can't take out a number. But what do you see on the three terms? They've got what that's common. And there's your hint right there. X. All right. And there's an X in every one of those terms. All right. Now, what do we have left? We have 4x squared minus 12x plus 9. All right, now again, this is going to be following that same pattern as this, because look at this. This right here is 2x squared, and this is 3 squared. Let's just write it down and see if it works. It's minus in between because of that minus sign. And see, 2, well, let me go ahead and write like this. All right, so 2x times 3 is 6x. 6x times 2 is 12x. So we got a perfect square right there. So that's the final factored form. All right, any questions about that? All right, let's see what's up on the top up here. All right, factor completely. All the messy ones are at the bottom. So any common factor between all of those three? All right. Both of these, 54 and 39, are divisible by 3, but sadly not 8. So what we got to do is we got to do that long method like I use, or you can use whatever method you do know about, because as I said is, there are other methods, and that's the method I use in order to factor trinomials of this type. Remember, when the number in front of the x squared is more than 1, then it's not as simple as just finding the two numbers that multiply out to be the last number and add up to be that. We got to use a slightly different method. Who is a Finch? Oh, Shante. Okay, I got you. I'm sorry. I just never seen you just have that last name on there. I got it though. I'd even already had it. All right. All right. So 54 times 8. So what is that going to give us? It's going to give us a large number. We're going to have to have it. So 432. So we got to break it down, and that's just all there is to it. Let's see. Kind of easier for me to do it on the side, and then all right, we need the numbers that multiply out to be 32 and have a difference of 39. Now, here's the issue. Those numbers that have a difference of 39, they're going to be bigger. So let's see. Probably not going to have enough room here, but Okay, 6 and 72. The difference between that is not 39. Let's say. Let's see. So that's not it. All right. So this has got just a little bit more to go. This is 2 times 3. All right. So we want. All right. So this is going to be, what is that, 8 times 9, right? So this is easy. That's 3 times 3. And then this right here is just going to be, it's hard to put the room in there, but that's 2 times 2 times 2. So now we're just going to take and all right, let's see if we can get this. May have to come back to this. This is too tough of a problem for a review, in my opinion, but they decided to put it on here, so we're going to go through it. Okay, so 9 times 8 times 6. All right, so we're going to have 39, so we're going to have the biggest one is the positive one. So 6. All right, so I think that's it. 6 times 4 times 9. 6 times 3. I think it's all right. So 6 times 3. 6, 4, 32. 18. All right, I'm gonna come back to that one. All right, that was just like too much for review, but we'll come back and get it. I just want to be able to make some room here because you got to find the factors and look at a bunch of factors. If you can figure it out, I'll come back to it and do it too, but I'll do it later. I just want to make sure we got enough time here. Now, this one right here has got a greatest common factor. All of these are even, so they're at least divisible by 2. And I happen to know that each one of those is divisible by 4 because 4 goes into 28 7 times, 4 goes into 48 12 times, and 4 goes into 4 once. So we can do this. All right. So see that when you take out a greatest common factor, and that was the thing I've been itching to show you. you are able to find out that this thing no longer has a number in front of the x squared that's larger than 1. So this can be factored fairly easily. We're looking for the numbers that multiply out to be 12 and add up to be 3, and that's 4 and 3. And they're both negative. All right. And you need to keep the 4 there for because it's just factoring. All right. That's one of the factors. Any questions about that one? All right. Now this one again, it's very much akin to each of these. They were perfect squares, but you remember there's what you have here is a perfect square. This one up here, since it doesn't have that middle term and it's got a negative sign, it's very much akin to this because this is equal to, because that's again, that's that 3x minus 2 times 3x plus 2. You can also handle it as if you want to look at it that it's 0x is in the middle, you can simply multiply the 4 times 9, get the factors of 36 that happen to be opposite of one another, and handle it that way if you want to. Because 36, 4 times 9 is 36. And since it's negative, you're looking for the two numbers that are factors of 36, so that's 6 and 6. So you can handle it like this if you want to. And you should get to the same spot. Out of here, you got 3x. Bring down that sign. And then there's 2 there. So same thing happens. You got 3x minus 2, 3x plus 2. So you can still handle them like that. It's just that one of the things that when we bring these up, like these perfect square ones, not that one, but these two, is that there's a shortcut to them by following that pattern about the ends, the ends being squared and the middle being twice the sum of the middle terms. All right. Any questions so far? Like I said, we'll come back in a bit to that last one. I just don't want to spend too much time on it. All right. What do you think about number 20? All right. It's got a negative in the front. So if you want to handle it like that, you can. I hate those when they do that. But the best way to handle it, I think, is just to factor out the negative sign and then just factor it as All right, again, we got one, and they probably got too much of these in here like this, but let's go to this one, come back. All right. What I would do is just take out that negative sign, which is just basically a negative sign or a negative one. And then you got x squared plus 6x minus 40. And then what you can do is then you factor that one, then you can run the negative sign back through. It doesn't matter. All right, so we need the factors of 40 that have a difference of 6, and that's 10 and 4. Pretty easy. All right, so this one factors as negative x, and it has to be the largest one is positive. So there's your factored form. Just keep that negative sum in front. We'll come back to that one in a second. Factor completely. Again, look for anything that's common to both. That's the first thing to do. What's common to 98 and 50, and then you also got the x's and y's in there. Since they're both even, that's going to mean at least 2. And there's a y that's common to both. And when we take out that, we got 49 x squared minus 25. And you know what? Now that's very similar to this one. Let's see. 49 and 25. It's very similar to this one because these are perfect squares. All right, take a look at that one and see if you got any questions about it.
Mr. Cruz,
So,
can you go over like your little tricks for the signage again? Because I always get my signs mixed up. Like, how do you know that
all
one's
right, so
like, how do you know
let's
that?
go back to this one right here. This was actually plus, and I think I messed up here, did I? No, that's right. That was right. All right. Let me give you an example. I was looking for the simple ones here. All right. Let's look at this one right here. This is the best one to start. If this number right here is positive, the last number when it's sorted like that, then both of the factors have to be the same sign. And that same sign is determined by what the middle sign is. Now, let's look at another one. So, in other words, if you had, this was probably prime, so that's a bad example, but anyway, that's the way you do it. Let me go ahead and find some good ones for you, because I want to, if you want to know about that, then I want to make sure I get it across to you well again, because that's a good thing, and it's taken me a while to kind of figure it out. All right, so let's look at this. So just remember about that test thing. I'm bringing it up again. We're in test time, and you got until tomorrow night. All right, so let's look. All right, so what we got here, we're going to write one. I'm going to write two of them, actually. But right here, if this is positive, okay, so if the last number is positive, then both of the factors that we come up with, the factors of 15, are going to be the same sign. All right. So in this case, it's going to be x plus, because that middle number is positive, so they're both going to be x plus. So that's 3 and 5. That's the only ones that multiply out to 15 and then add up to 8. All right, now that also applies to another type. If we had one that looked like this with that middle term, let's see. I think this is right. This also applies to this one as well. All right, x squared minus 7x plus 12. The third number is positive. So that means that both of the numbers have the same sign. Well, what is the sign of those numbers? Well, it's negative. So in this case, it's x minus 3, x plus 4. I'm sorry, x minus 4. Okay. So that's what I would call case one, right? Case one. In a sense, it's kind of two cases because the middle number is different in each case. But if you just follow this one scenario, that if the third term is positive, then both numbers are going to be the same, and the sign of the middle number determines what the sign is going to be. In this case, they're both positive. In this case, they're both negative. Does that make sense for that case?
Yes. Yeah, that
All
makes
right.
sense.
Let's look at the second case. I like to boil it down to two. All right. I want to find one that was factual. So just hold on just a second. Let me find one. I just found something that's kind of interesting, and I might show you. It's kind of it's basically what I'm telling you. They break it down into 3 cases, but they consider those first 2 as 2 cases, the ones I just showed you. So, all right, let me just find one here. Okay. All right. So here's the second case. If the third term and when we say different, there's only 2 choices, negative and positive. Okay.
Okay, yeah, that helps a lot.
Okay, so let's look at that case. So what you're going to have is different signs. So you're going to have an x plus and an x minus, because that's negative. So the only way that happens is these are different signs. So you need the factors of 16, namely 8 and 2, which have a difference of 6. Since 8 minus 2 is equal to 6, then the larger number will have that sign. So the 8 will go right here and 2 right there. Now, if it happened to be like this, then this part would be different on which one gets picked. Let's just say this was negative there now. It's still under this larger case. All right, still under the larger case that we've determined here. But the sign in the middle is negative, so that means now that the middle term determines that, so the 8 will be over here. All right, so that pretty much sums it up. I mean, it's a matter of those 2 scenarios. And this is, I don't know, that probably shouldn't show this. I don't think this is complete. But that's really it in a nutshell. If you follow that, you shouldn't you won't go wrong.
That helps me. Thank you.
All right. Well, anything else, just yell, because I hate to just be working these out, if they're not doing you any good. All right. So this one's 4 terms. So that means that we got to use factoring by grouping. So let's say here. You got x's in both and you got even numbers. So 2x on this side. Five y, and then that determines the sign. It's negative. The third term always determines the sign that goes right there. All right, so now again, here it's not 2, it's 3. 18 and 15 have the common factor of 3, and there's a y in both. So 6, and you can find this by just taking this and dividing it into each one of those. And this is negative, so this is going to be positive, negative into negative. Gives you the positive. There's your repeater, so you got 6x plus 5y times 2x minus 3y. So one of the reasons why I use that factoring by grouping or what they call the AC method for factoring ones, sort of like this, and the ones we looked at down here, is because you got to know factoring by grouping anyway. They're going to throw one of those at you like that. That's already got the 4 terms, and you just have to factor by grouping. All right, I think this one is going to be prime, if I'm not mistaken. Are there any factors of 48 that have a density of 2? Wait a minute. Maybe not. So 48. So there's 48 and 1. I'm sorry, they have to be the same sign. So I don't think that that's going to be possible. If this was a negative, it would be, but I don't believe there's any factors of 48 that add up to 2. So factors of 48 that add up to 2, you can kind of put them all here and see. Since that's positive, that means they have to add up to 2. 48 and 1. 24 and 2. 12 and 4. 6 and 8. I think that's all of them. And none of those add up to 2. Because I was thinking at first, if that was a negative right there, then you could get 6 and 8. But this one is what we call prime. Put it right there. So that one can be factored. But don't use that too often. Try and factor it first. Make sure that there are no factors. See, like I said, I skipped a couple because they're harder, so I'm going to come back to them. So what I'm trying to do in a way is kind of show you how to test. Go along to the easier stuff first. Do that. Don't get bogged down in things that are too complicated. Because if it's too complicated and you're spending too much time on it, go on to something that you know you can do, and then you can come back to the harder one. Because in a sense, on a test, everything is worth the same amount of points. So you don't want to spend your whole test time on something hard and then forget about the easy stuff. Okay, again, take out any common factors, and it looks like 2 is common, and the smallest power of x is x squared. If you do that, oftentimes the factoring won't be nearly so hard. And then this is minus 45. All right, so we need, and let's put this to use, we need factors of 45 that have a difference of 4. Let's see, there's 9 times 5. And look at that, it's the first one. This is a different sign, so one's got to be negative, one's got to be positive. This determines what the larger number, or it determines this right sign of this one determines the sign of the larger number. So x minus 9, x plus 4. And you can kind of check it out. X times x is x squared. X times 4 is 4x. Whoa. This is 5. Sorry. That's the importance of checking it. X times 5 is 5x. Minus 9 times x is negative 9x. 5 minus 9x is negative 4x. And 9 times 5 is 45 negative. So that's it. Any questions about that? All right. I think there's plenty of factoring on here. Well, that's what most of the chapter is. So again, look for a common factor. You got a y and you got an x, And then these are both even, so that's 2. Because 18 is divisible by 2, but not 4. So, well, actually, none of them are divisible by 4. So 2x, y. So then that's going to be 9x squared plus, and then it's 7y to the 4th. And this cannot be factored any further because it's got, you can't factor that any further. If you've got 2 terms and there's a plus sign in between, that's a good indication that you can't factor it any further. And I'm sure we're going to see another one on that. Now, remember, for the next one, I'm going to give you a reminder. These should always be written in descending order. In other words, if you write this one like this, then you can go and look for the factors of 63 because it's negative that have a difference of 2. So let's say 9, what is that? 9 times 7, right? And look at that. We hit it right on. Those two have a difference of 7. The larger one is positive, and then this one's going to be negative. So that one needs to be rewritten so that it's in descending order. Okay? Just remember that, because looking at it like that, you can't really see what to do. It should be written with the x squared term first, then the x term, and then finally what they call the constant term. All right, this is another one that's going to be factoring by grouping because it's 4 terms. That's when you use factoring by grouping. 4 terms. All right. So just break it in half like that. Take anything you can over here. You could rewrite them if you wanted to, but it's not going to make any difference. You just take out the common factor of each, and it looks like it's 8. And then that's x plus 10. Bring down that sign. What's common between both is just a y. And then it's x plus 10. See, that's factoring by grouping. You end up with that repeating factor that you're only going to write once. So that's, again, factoring by grouping. Oh, we're going through these pretty quick. We still got those couple that we didn't do. All right, any questions? We got plenty of time, so I thought it would take a time. We could look at that other review too. So start looking at that next one there. Now we're actually doing some solving. All right. So again, to solve these equations right now, all we're doing is we're using factoring. So if there's a common factor in all of those, always look for taking the greatest common factor out first. If there's not, then you're going to factor it the whole way. And again, they got to put a tough one in here, but I'm sure there's going to be a couple other easy ones there. I just having to put the harder one there at the bottom. All right, so 3, there's no common factor between 3, 20, and 63. If it went for the 20, if there's another like 21 or 18, we could do it. But so what we're going to have to do is do 3 times 63. Wait a second, I got this other calculator here. So 189, and the signs are going to be different. So these numbers have to have a difference of 189. I'm sorry, of 20, difference of 20. So let's look at 189 and see what we got. So 189 and 1 is the most obvious. Does 189 factor by 3? So that's 63 times 3. We know that anyway, because we just did that. All right, so we need to get these numbers closer together. 63, so let's see, that's 21. And is it 9? So that's right, but the difference here would be 12. So not this one, not that pair. All right, so let's see. Let's take out another 3. So 7 and 27. So what I did, I just started getting my mind around this lately. But what I did in order to come up with this one, 21 is divisible by 3. So I took the 3 out and multiplied it times the 9, and 3 into 21 goes 7. So 7 and 27 are magic pairs because they multiply out to be 63 and they have a difference of 20. Put the so we need the larger one as negative, so let's make that one negative. All right, I'm just going to factor it, and then once I get the factors, I'll set it back to 0. All right, so over here we got 3x is the greatest common factor. Bring down the plus. 7, and then it's x minus 9. There's your repeater. All right, so then here's the factored form. It's 3x plus 7. And I'm going to probably have to go over to the other board because it's not enough room. We already used too much room. All right, so let's just see if I can do it up here. So these are now equal to 0, back equal to 0. So now we use that property, the multiplication property of equality. Set each one of these equal to 0 and solve each one separately. So that means x is equal to 9 on the easy one. And then this is 3x is equal to negative 7. And then divide both sides by 3. So x is equal to negative 7, 3. So there's your two solutions. All right. So the point of learning the factoring was so that you could solve equations by factoring. All right. Any questions about that? All right, I'll tell you what, let's back up and go back down to Probably should take a break after this one. All right, there's nothing common to all. So 20 times 6 is equal to 120. All right, so factors of 120 that add up to be 23 because they're both positive. Well, actually, this is the only one we need to know to be a positive. This is positive, then they're both going to be the same sign, which is positive. All right, so we got 120 and 1, which is obviously 121. That's not it. Let's say factor out of 3. And then this is 60. So 60 times 3 is 120. But those add up to 63. So take out another 3, it looks like. This one may not be factorable. Let's see. They usually don't put like one of those on there, so I'm kind of suspicious about it. No, they're there. So they have to add up to 23. So 3 in 60 is 20 times. Let's see. So let's take out a 2 and multiply that. So that'd be 18 and 10. Is that right?
I think it's 15 and 8.
All right, thank you. So it's not either one of those. I messed this one up anyway. So the 2 come out. So 15 and 8, thank you. So that's the one we want. So that's the main thing. You don't have to go through all of them. You just got to find the 2. But sometimes you got to go through a bunch of them. I got y'all here to help me, so that's good. This one will be pretty frustrating. So now we're going to rewrite this with 4 terms. It doesn't matter which one goes first. It'll still work out if you put the 8 first. So we're going to use our factoring by grouping. So 5x here. And then that's 4x plus 3. Bring down that sign. 2. 2 goes into 8x, 4x times. And 2 goes into 6 3 times, positive. You see, you got your repeating 1. That's what should happen if you did it right. All right, any questions? Let's see, this was the one that I wanted to do. I'm going to handle this a little bit different than I did before. There's really not enough room as part of the problem. One of the things that I would also tell you about testing, make sure you got plenty of paper, because you see how I'm trying to squeeze that in there. it would be a lot better if I could go to a different sheet of paper. And that's why I go over to the board sometimes. All right, so 54 and 8 times 8. Make sure I get this right. So 432. All right. So that means these got to be different signs and have a difference of 39. This sign right there means they've got to be opposite signs. But for right now, we're just going to find the factors of 432 that have a difference of 39. So 432 and 1 is obviously not it. Let's see, 7, 8, 9. This is divisible by 3. So 144. All right, but that's still not a difference of 39. So we don't want that. 4, 8, 9. So this is going to have, this one is also divisible by 3. 144 divided by 3 is 48. And if I take that 3 out and multiply it times that 3, it's 9. I think we got that, what we need, right?
Yeah.
I like this. This method works a little bit better. I don't know why. I just all of a sudden started seeing this. Rather than write out like I did over here. And this, like I said, it works. It's just that it can be a pain in the neck. I think I already see like this. I mean, that works to bring it down into all the possible factors, and you can just try different combinations. But what I was doing here was just started out with the big one and did with 1, and then look what this is factorable by. And this is one of the things I learned years ago, that if the digits add up to something that's divisible by 3, in other words, 4 plus 4 is 8 and 1 is 9. And if that number is divisible by 3, then the whole number is divisible by 3. So that's how I was able to take that 3 out, put it there, multiply it times the 1, and then 3 goes into 48, 144, 48 times. And that gave us the one we needed. I'm going to have to remember that. Like I said, it just occurred to me to start doing it like that. And I like that a lot better. Sometimes the formal ways that people show you are not necessarily the best way. You got to go with what makes sense to you. All right. Oh, I'm sorry. And I messed up. This is negative. Shoot. I don't know how. How do I get that? I know how to fix it. There we go. I was thinking that there wasn't a race, but they got draw with white. That works. There we go. All right. So now just what in the world did I do? Oh, I know what I did. This seems kind of temperamental, but I'm learning it. That's supposed to be a negative sign. All right, so you got to click over here, then change the sign. It doesn't change the color, so it doesn't make that. There we go. All right, so now let's just factor by grouping. Over here, we got something x. It's 4. I believe it's 4x. 54 divided by 4. Nope, it's not. It's going to be 2. 8. Actually, you know what it is? I think they're both divisible by 3. Yeah, that's what it is. So divisible by 3x. So 3x into 54 x squared is 18x. And then 3x into 48x is 16, right? Yeah, and that's plus 16. Bring down that sign. And the only thing that's common here between 9 and 8 is just a 1. Whoop. That's still going to be right, but I'll come back. So it's 6x. I knew it was divisible by 3, but all right, here we go. So 54 divided by 6 is 9x. There we go. And then 6 into 48 goes 8 times, I believe. Yeah. There we go. If they don't match, then it means generally you didn't take out the largest one. You saw what I just messed up there. So that sign comes down. And that's the only factor is just the -1. So this is 9x plus 8. So we just write the repeated one. There we go. All right, let's take a little break. If you got any questions, though, I'll stay here for a few minutes, and then, like I said, we'll take back up with the other ones when we come back. I wanted to do the pause recording. So, and then we can look and see if there's anything else on that other one that is, that might fill in some gaps. All right, all the other ones are equations. So, like I said, is the reason why I started at the bottom is because this is the last stuff we did. This was the last 2 sections. This was the application section, these 2. And these are the good ones. I'm glad they don't have any of these on here about the triangles. Those are a pain in the neck. And then there's 3 other equations. Now, what you're dealing with when you're dealing with equations that are quadratic like this, or like I said, is they got an x squared term, is you have to use factoring to solve them. So here, this is just these right here are going to be the easiest ones we've seen. We still have to factor them the same way that we were factoring down here. So this factors as, I'll tell you what, put on some glasses. All right, so they're going to be different signs because the 6 is negative. All right, the 6 is negative. So that's x plus, and then x minus. All right. So we need factors of 6 that have a difference of 5. Well, hopefully That shouldn't be too hard because there's only two factors of 6. This has a difference of 1, so this is not it. These have a difference of 5. Now, if this had been positive, then this would be what you need here. So I suspect this one's in here for that very reason, to make sure you understand that. So since this is negative in the middle, that means the larger number goes here. And so there, really pretty easy now compared to everything else we've been looking at. All right, any questions so far about that? So this is just now x plus 1 is equal to 0, or x minus 6 is equal to 0. So x is equal to negative 1, and then plus 6. Plus 6, so x is equal to 6. And we can kind of just spot check. Let's see, negative 1 squared is 1. So positive 1, negative 1 times negative 5 is 5. 5 plus 1 is 6. 6 minus 6 is 0. So we got a solution there. And like I said, I know, like when you're in a testing situation, you don't want to have to rush and think about checking. But if you do your check-in while you're doing your homework, it eventually builds confidence because you get a good idea of how often you make mistakes and whether the checking is necessary. So anyway, 6 squared is 36. Negative 5 times 6 positive is negative 30. So this is 36 minus 30 leaves you 6. 6 minus 6 is 0. So you don't necessarily have to write it out unless you want to. But I'm pretty good at doing these things in my head, so don't expect that you should have to do that if you can't. All right. All right, now remember, for an equation, or, now over here, we don't have to worry about it because over here, when we're just factoring, these things are not an equation, so they're all going to be on the same side of the equal sign because there is no equal sign. But when we're dealing with equations, we have to have all of our values simplified, like terms collected, and set equal to 0. This one is not like that. So what we got to do is we got to minus x both sides. And so that's going to go smack dab in the middle. So we've got x squared minus 8x minus 9. And see that's the 0. Because there's nothing left over there now. Now we can proceed and factor this. So the third term is negative, so it's x plus and x minus. And then once we find, so what we're looking for is factors of 9 that have a difference of 8, and then the larger one is going to go here. Now, there's only 2 factors of 9. There's 3 and 3, but these have a difference of 0, so that's not it. But 9 and 1 have a difference of 8, so there's our pair. Remember, this sign determines what the larger one is going to be, so that one goes here. So this is pretty easy now compared to all the other mess we've been dealing with. All right, so minus 1 X is equal to -1, or, so this is going to be +9. So there's our two factors, -1 and 9, or our two solutions. So we can just check, let's say -1 squared is 1. 1 minus 9 is -8. -1 times 8 is -8, so this is good. Like I said, if you have to write it out to check it, by all means do it. I just don't really have enough room on here. And like I said, that's kind of bad form in a way, but, you know, it's just a matter of time, you know. So 9 squared is 81. 81 squared minus 9 is 72. 8 times 9 is 72. So that one's good. All right. Any questions? All right. Now this one, this is an equal sign there. It's just not very clear. This one doesn't have a third term. So there's only one way to factor it, and that's by using the greatest common factor. So set equal to 0. So we still use factoring. So take x out. So that's how this thing factors down. Now, once we do that, we set those two factors equal to 0, just as normal. It's just on this one's going to be just 0, so there's nothing really to do there. So x is equal to 3. All right. So you can see that this is the solution. 0 squared is 0. Minus 0 is equal to 0. So that one works. And then 3. 3 squared is 9. And then 3 times 3 negative is -9. 9 minus 9 is 0. So all right. Do y'all remember how we handled this one in class last time? This one might be easier to do first. So height, when hit the ground, means h is equal to 0. So replace that see if you can solve that. I'm going to give you a few minutes. See if you can come up with anything on that, and I'll jump in. All right, what can you do with that one to solve it? Here's your hint. Always look for the GCF. Greatest common factor. Yeah, good. So what's the GCF? You could go ahead and factor this any way you wanted to, and it will probably work, but it'll make your life a lot easier if you take out that GCF. And I would also take out that negative sign as part of it. All right. So what does it look like when you, yeah, you can do it with 16. This is the issue that I don't like, is that you're going to have then a negative t squared. And if you know how to factor them with that, then that's great. I just, it always irks me if that leading term is negative, just like down here. That's why I factored out a -1. See on that one? That way I can use the kind of proceed with factoring as normal, I guess you could say. And some people know how to do it. I mean, I've run across students that can do it. I just don't like doing it. And I probably could if I really had to, but I don't want to. So that means we're going to have -16 times t squared minus 1. Oh, sorry. How much is how many times 16 going to 144? I think it's so this is 9. So this is just kind of the way it works. So this doesn't have an X with it, then it really doesn't give any value. So you can just go ahead and solve this. All right. Which factors as t minus 3 times t plus 3. So what are the two solutions? Well, we got so that's going to be t is equal to 3 or t is equal to -3. All right. When? All right, here's where we got to watch out. Whenever we're dealing with things like time and lengths and widths, we got to watch out because areas can be negative, lengths can be negative, widths can be negative, and time can be negative. Now, that's why our only solution we're going to worry about is t is equal to 3. T is equal to 3. All right. I can't remember if I showed y'all this, but I'm going to do it again. If not, I think I did, but. All right, this is plus 96. Oh, it's 144. It doesn't really matter about the variable. They only want you to use x's here. All right. So how come we're able to take out that greatest common factor, have a brand new equation, and yet get the values that make it zero? Well, it's because of this. The red one is the original equation. And remember, what that has to do with is what's called a position function. When this thing shoots up in the air, well, it's actually dropping the bucket, but it's still following an arc. Anyway, it's just the coming down part. It's just this part. He's up here. It's just way up there. So he's up here and he drops it. And how long does it take to get to the ground? Well, that's what the 3 seconds is all about. Taking 3 seconds to bottom that. Now, if we take out the greatest common factor, notice we got a completely different equation. It doesn't look anything. As a matter of fact, it's almost a mirror image. And it's not even that because it's fatter than the skinny one, the red one. But it crosses, because of the greatest common factor thing, it crosses the x-axis at the same points. So that's why this works. So both of these have a solution at x is equal to 3. Now, just kind of the, well, I'm not worried about that. But just might mention that these kind of things are things, anytime you're shooting things into the air, like if you shoot a bullet up in the air, you throw anything in the air, football, mortars, like in the Army, they follow an arc, and the way they determine how to put a mortar in the right position is by doing some simple measurements. And they probably have a book. They don't have to do these calculations by hand. They have these calculations so they can know what angle to put things at in order to put it in the position that they want. Because remember, see, these all have to do with angle. See, that's an angled upward. Because when it gets up to the top up there, it's, at one point. All right, so last one. I'm going to let y'all do this one, and I'm actually going to do that sleeping we were talking about at the beginning of the class. Just kidding. I'll be back in a second and show you. Remember, what this is saying is C is equal to 8,000. All you're going to do is just replace C with 8,000 and then simplify. All right, anybody on the trail yet, on the hunt? Give you a couple more minutes since this is the last one. Like I said, we'll go over to that other sheet. Now let's look through it to see if we've got anything else we can do. How would the initial setup of this look? What's it going to be equal to? Good. I'm having trouble drawing it, but all right. And just like any other equation, we got to set it equal to 0. So we're going to minus So there we got our equation. All right, so different signs. So it's x plus and x minus. Now, once we determine out what the factors are, the larger number is going to go here because that's negative. So let's see. I think if we just kind of think in terms of 70, we can probably, so 10, so that means 100. So 10 times 7 is 70. So that would be 170. Have a difference of 30. But we want the larger one to be the negative and the smaller one to be the positive. Oops. So the 100 goes here and the 70 goes there. So what are the solutions? Yeah, because you're gonna let's see, let's put them over here. X plus and X minus so and then that's going to be X is equal to negative 70. And X is equal to 100. All right. So we're talking about number of units that can't be negative. So here's our solution right there. So 100 units. 100 units brings a cost of $8,000. All right. Any questions about that? All right. Any questions about any of these? I'm going to go over on that other sheet. So we still got about 10 or so minutes. But if you got any questions about any of these, shoot. All right, let's see what's over here. Now this one's got some different kind of things on it. Greatest common factor between 3 and x. What is it going to be? So 3 is the only one. Yeah. How about on this one? Greatest common factor. I think it's 4a 5b4, but I'm not sure about the number. Let's see. Is 56 divisible by 4? They might be divisible by 8. Yeah, it's 8. And then you're going to take, you got a 8, a to the 5th, so it's going to be the smallest one. And then the b's, smallest one. There we got it. Oh, yeah, you're right. It's b to the 4th. Thanks. I don't know what. It's on the 5th. Because it's the smallest power of b. So it's 4th. With this one, let's see. All you can do, let's see. We did one like that. We did several of those. We like done more factoring by grouping than we needed to. Again, this is factoring by grouping. There's one where we turn around. Let's see what can be done with this one. All right, so 5 is the obvious number. And then look at the smallest power of x, which is x, and the smallest power of y. So 5xy goes into 45, 9 x to the 4th. No y's left over. 5 into 40 goes 8 times. And then the x's don't need to be worried about because it's going to be there. And then y to the 5th. And then that can't be factored anymore. Again, this is one where I would factor out the negative sign and then just look for the factors of 36. Because when you factor out the negative, it's going to be x squared plus 9x minus 36. And so you got to just remember there's a negative sign in front. So you factor this, find the factors, and then just leave the negative sign out in front. We did one like that. That's another factoring by grouping. This is one where you got to turn it around. It looks like the exact same one that was over there. Because if it's not in that form, you're not going to be able to, it's going to be hard to see what numbers you need. So you just need 2 and 5 that have a difference of 3. Let's see. So this has got an x to the 4th. Smallest power of x. And they both, all these have a 4 common. So this is x squared minus 8x. And then minus 9. And you know what? That's factorable in there. Because that's the same one we factored earlier in another problem. So it's going to be x plus and x minus. All right. So factors of 9 that have a difference of 8. So that's 9 and 1. I think we did that we did that exact same problem over there. The only thing that can be factored out of here is an A. And this can't be factored. If there was a negative sign in front of it, we could do it as 4A minus 3, 4A plus 3. But with that plus sign in the middle, that's considered prime. Now there was one factor took out, so the whole thing isn't prime, but this can't factor any further. We did that one over there. Let's see. So this one they had actually in the right direction, but it's the same problems. Let's see. All right, any of these anybody want to particularly see? We just got a few minutes, so this one I think we had that one over there. That's the difference of squares. That's 6x minus 7, 6x plus 7. The way you can factor it, if you can't recognize that form, is just there's a 0x in the middle, so you're looking for the fact you got to multiply the 36 times 49. So that's a pretty tough way to do it if you don't recognize that. But what about that next one there? Any ideas? Not, I know that's a new problem that wasn't on the other one, but it's one that's going to take a little bit of work to do it, because you got to do 5 times 12. So that's going to be 65 times 12. So we need to have a difference of 11 because this is negative. So they're going to be different signs. So let's see, 30 and 2 is obviously not, well, 60 and 1 obviously is not it. 30 and 2. 15 and 4 are the ones we want. That's what we want because they have a difference of 11. All right, so factor my grouping. So 5x. So then this factors as x plus 3, the repeated one, times 5x minus 4. These are just solve. We looked at one like that. I mean, this one is just both the same sign and they're both negative. Because 6 and 1 multiply out to be 6, and then, no, wait a minute. Whoa, 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 whoa. Whoa, 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 whoa. I don't think this one is factorable. Now that I see it, I just wasn't paying attention. This is because the 6 is plus. Oh, I don't know what I'm thinking. I'm crazy. I'm just crazy. All right, they're the same sign, and they have to add up to 5. So it's obviously 2 and 3. Yeah, so you got to watch stuff like that. You almost fooled me because I'm tired here. At the end of the day. So there we go. X is equal minus 2 is equal to 0. Or x minus 3. So x is equal to 2. Or x is equal to 3. There we go. This is the one where you're going to have a 0. In other words, it factors like this. So we had one like that. So x is equal to 0. Or x is equal to 4. All right. This is another one like this up here. This is really pretty much just like sort of like what we looked at, because you got to subtract that 16. So and then that's the difference in squares. So that's x minus 4, x plus 4. So to cut it short, x is equal to 4 or negative 4. And that's one was it. So that's probably enough unless you got any questions. I mean, this one is just going to be multiplying and doing it the long way. But I can do it like real quick and show you that it factors as this. However you want to factor it. So there's the two factors. 4x minus 7. You can go through that factoring by grouping to do it, but I'm trying to cut things short. But you got answers over there, so at the bottom on this one. All right, anybody got any last questions? Remember your test again. So when we come back Thursday, this test has been gone for like 18 hours or so. So don't all right. Test always ends before, because I could make you take it in class today. That's what I'm supposed to be doing. So just remember, you're getting a little extra time, so you got to make a decision on when you take it. So if you squander your time and think, oh, it's just 11 o'clock, I should be able to take it, and your power goes out, especially with the kind of weather we're having, then